In this video, I'm going to talk about Euclid's Book 1, Proposition 11. And the first thing he does is he gives us a straight line known as AB. He then gives us a point on that line, which is point C. And what he wants is a line, this one right here, this CF, that's constructed perpendicular to AB. Now the first thing he wants us to do is to pick yet another point called D. And what he wants us to do is he wants us to draw a length, this length of DC. You see this length DC right here? He wants CE to be equal to DC. Now how are we going to do this? Well, first of all, we're going to use Euclid's Proposition 1, 2. And we're going to make an equilateral triangle. And it's going to be DGC. That's triangle DGC. Alright. And when we extend these lines out here, what we're going to do is we're going to have it make center point D, outermost point C, and we're going to strike an arc. In other words, we're going to make another little circle, okay? Centermost D, outermost part C, and we're going to have another point called H. And then we're going to go to centermost part G, outermost part H, strike yet another arc, and make point I. And then we're going to take centermost part C, outermost part I, strike yet another arc, and make point E. Now, let's start. DC equals DH because all radii of a circle are equal. And GH and GI are equal because all radii of a circle are equal. Now, if you take equals away from equals, all you're going to have left is equals. So, if we subtract GD and GC from GH and GI, then DH equals CI. Okay, and that's by Proposition 1, 2. Now, what about Proposition 1, 3? Well, if we make centermost part C and outermost part I, we make CE, then we have said DC equals DH, and then DH equals CI, and of course by the transitive property, CI equals CE. And so therefore, DC equals CE. That's the rest of the transitive property right there. Alright, now that we've done that, we form yet another equilateral triangle, DFE. And because of this, we can safely say that DF equals FE. Why? Because in an equilateral triangle, all sides of the triangle are equal. Alright? Now, we draw a line here from F to C. Well, CF equals CF, that's kind of pretty obvious. An equal is equal to itself. Alright? Now, we already said previously that DC and CE are equal, and that is because of the transitive property. Okay? So therefore, triangle DFC is equal in size to triangle CFE. And if you have two triangles that are equal in size, then all the angles inside that circle, or in those triangles, are equal. And in this case, angle FCD is equal in size to FCE. And by Euclid's definition 110, which I quote, when a straight line set up on a straight line makes the adjacent angles equal to one another, each of the angles are right. And to put it simply, since angle FCD is equal to FCE, then FCD is a right angle and FCE is a right angle. And that's it. That's the proof. Alright, I will tell you more in a future video, so stay tuned.